electric hot water tank connected with a cord and plug, similar to a range or dryer, is a situation that demands careful evaluation against prevailing electrical codes. The National Electrical Code, or NEC, provides the overarching guidelines, but local amendments and interpretations can significantly alter the permissibility of such installations. Because I cannot access the image, I cannot give a definitive statement about the situation in the picture. I can only offer a discussion regarding the relevant NEC articles. Firstly, consider NEC Section 422.16, which addresses flexible cords for appliances. This section generally dictates under what circumstances an appliance can be connected via a cord and plug. Several factors come into play. Firstly, the weight and size of the appliance. The NEC typically permits cord and plug connections for smaller, easily movable appliances. Hot water tanks, particularly those of significant capacity, are not generally considered portable appliances due to their size and weight when filled with water. Secondly, consider the ampacity of the circuit. Hot water tanks, especially those designed for rapid heating, often require dedicated circuits with substantial amperage ratings. Verify that the cord, plug, and receptacle are appropriately rated for the load, meeting or exceeding the tank's amperage requirements. It's crucial to refer to the manufacturer's specifications for the hot water tank to determine the precise electrical demands. Thirdly, consider the purpose of the appliance. The NEC often differentiates between portable and stationary appliances. Portable appliances designed for frequent relocation are more likely to be permitted cord and plug connections. Hot water tanks are typically considered stationary appliances intended for permanent installation. Fourthly, review NEC Section 110.3b, which emphasizes that all equipment must be installed and used in accordance with the manufacturer's instructions. If the hot water tank's installation manual explicitly allows for cord and plug connection under specific conditions, those instructions must be followed meticulously. This may involve using a specific type of cord, plug, or receptacle, and adhering to limitations on cord length. Fifthly, consider the local amendments to the NEC. Many jurisdictions adopt the NEC as a baseline, but introduce their own amendments to address local conditions or specific concerns. These amendments can be more restrictive than the NEC itself, potentially prohibiting cord and plug connections for hot water tanks even if the NEC might otherwise allow it. Local electrical inspectors are the definitive authority on code compliance. Their interpretation and enforcement of the code are binding. Consultation with a local electrical inspector before installing a hot water tank with a cord and plug is highly advisable. Sixthly, the type of receptacle plays a role. If a 240-volt receptacle, similar to that used for a range or dryer, is already installed in the vicinity of the hot water tank, it might seem convenient to utilize it. However, the presence of such a receptacle does not automatically legitimize a cord and plug connection. The receptacle must be appropriately rated for the hot water tank's electrical characteristics, and the installation must still comply with all applicable codes and manufacturer's instructions. A 30-amp receptacle that matches the plug is crucial. The cord needs to be appropriately sized as well. Seventhly, the grounding and bonding requirements are paramount. Ensure that the hot water tank is properly grounded according to NEC Article 250. Improper grounding can create a significant electrical shock hazard. The grounding conductor within the core must be correctly connected to both the tank's grounding terminal and the grounding pin in the plug. Eighthly, protection from physical damage is important. The flexible cord should be routed in a manner that protects it from physical damage, such as being pinched, crushed, or abraded. Avoid running the cord across walkways or in areas where it could be easily damaged. If physical protection is a concern, consider using a more robust type of flexible cord or installing a conduit system. Ninthly, proper overcurrent protection is essential. The circuit supply in the hot water tank must be protected by a properly sized circuit breaker or fuse. This overcurrent protection device safeguards the wiring and equipment from damage in the event of a short circuit or overload. The size of the overcurrent protection device should be determined based on the ampacity of the hot water tank and the wiring. Tenthly, consider the accessibility of the disconnect. The NEC requires a readily accessible disconnecting means for appliances. This disconnect allows for the electrical supply to be quickly and easily shut off for maintenance or in case of an emergency. If a cord and plug connection is used, the plug itself can serve as the disconnecting means, provided it is readily accessible and within sight of the hot water tank. 11thly, the cord's length is important. The NEC typically imposes limitations on the maximum length of flexible cords used for appliances. This is to minimize voltage drop and ensure safe operation. The cord should be long enough to reach the receptacle without being excessively strained, but not so long that it creates a tripping hazard or excessive voltage drop. 12thly, consider the use of a power inlet. In some cases, instead of a standard cord and plug, a power inlet might be used. A power inlet is a permanently mounted receptacle on the appliance, allowing a detachable cord to be plugged in. This can provide a more secure and reliable connection than a standard cord and plug. If a power inlet is used, it must be appropriately rated for the hot water tank's electrical characteristics and installed in accordance with the manufacturer's instructions. 13thly, the type of wiring method used in the building is relevant. The NEC specifies different wiring methods for different applications and environment. If the building's wiring method is not compatible with a cord and plug connection for a hot water tank, alternative wiring methods may need to be considered. For example, if the building is wired with aluminum conductors, special precautions may need to be taken to ensure a safe and reliable connection to a copper cord and plug. 14thly, consider the presence of other appliances on the same circuit. It is generally not advisable to share a circuit with other high-demand appliances, such as refrigerators or air conditioners. Overloading a circuit can create a fire hazard. The hot water tank should have its own dedicated circuit with sufficient capacity to handle its electrical load. 15thly, arc fault circuit interrupter, or FSI, protection might be required. The NEC has expanded the requirements for FSI protection in recent years. Depending on the location of the hot water tank, FSI protection may be required for the circuit supplying it. FSI breakers are designed to detect arc faults, which are a common cause of electrical fires. 16th, ground fault circuit interrupter, or GFCI, protection may be needed. GFCI protection is typically required in damp or wet locations, such as bathrooms, kitchens, and outdoors. If the hot water tank is located in such an area, GFCI protection may be required for the circuit supplying it. GFCI receptacles or breakers are designed to detect ground faults, which can cause electrical shock. 17th, consider the long-term reliability of the connection. Cord and plug connections are generally less reliable than hardwired connections. Over time, the cord, plug, and receptacle can become worn or damaged, leading to loose connections and potential electrical hazards. For a stationary appliance like a hot water tank, a hard-wired connection is generally preferred for its long-term reliability. 18th, it is crucial to maintain clear access around the hot water tank. Adequate space should be provided for maintenance and repairs. The NEC specifies minimum working clearances around electrical equipment to ensure the safety of electricians and other service personnel. 19th, consider the potential for water damage. Hot water tanks are prone to leaks and condensation. Precautions should be taken to protect the electrical connections from water damage. This may involve using waterproof connectors or enclosures. 20th, the voltage rating of the equipment matters. Ensure that the voltage rating of the hot water tank, cord, plug, and receptacle are all compatible with the building's electrical system. Using equipment with mismatched voltage ratings can create a fire hazard or damage the equipment. For example, if the building has a 240-volt electrical system, the hot water tank, cord, plug, and receptacle must all be rated for 240 volts. In summary, whether or not a cord and plug connection is acceptable for a hot water tank hinges on a confluence of factors, including the NEC local amendments, the tank specifications, and the inspector's interpretation. A prudent approach involves thorough research, consultation with local authorities, and adherence to all applicable codes and manufacturer's instructions.